Chapter 8, Lesson 6. This is all about surface area of prisms. So we're going to be talking about surface area. We're going to come up with a formula, and we're going to hopefully generalize that formula so when we look at surface area of pyramids tomorrow, it's going to be a little bit easier to see where that formula is coming from. So surface area, first of all, is going to be the sum, or when we add, of the areas of each, and this is important, each face. So we're going to be talking about how to find the area of a pretty generic prism like this. First of all, we have the base, and in this case it's a rectangle. This right here is the base. We have a second one on the back side here, so there are two bases. So really what we're going to be looking at, surface area is going to be the area of the bases plus the area of the faces. So when we're looking at this, the area of the base is going to be this H times this W. And there are two of them, so we're going to be looking at 2 times H and W. Two of those. That's going to be the area of the bases of this prism. Next thing we want to look at is going to be the top part here. And of course its pair on the bottom. Now, the area of this face here is going to be this L and W. So we're going to be looking at adding L and W, but again, there are two of those. And then last but not least, we're going to be looking at the last side here as well, dealing with the front. So if I grab a different color here, we're now looking at this part here. And this area is going to be this L times the height. So this is going to be plus LH, and again there are two of those. So the surface area formula is going to be 2HW plus 2LW plus 2LH. And I know that's a long formula, but it's going to be very helpful to have that formula down. So, example 1, it says find the surface area of the rectangular prism. So here's the rectangular prism. So I'm going to write down the formula that we came up with just above. I'm going to write down what each one of these letters represents. So the length is going to be this 6 centimeters here. The width is 2 centimeters. And the height then would be 3 centimeters. And I'm going to substitute each one of these numbers where they go in the formula. So we have 2, H is 3, W is 2. L is 6, W is 2. L is 6 and H is 3. If I start multiplying each one of these, so 2 times 3 is 6, times 2, this would be 12. So the area of the bases is 12 centimeters squared. The face along the bottom here and the top would be 2 times 6, which is 12, times 2, which is 24. And the faces along the front and the back be 2 times 6, which is 12, and then times 3, which is going to be 36. So the surface area total, 12 plus 24 is 36, plus another 36 will get you 72 square centimeters. Now, because it's an area, that's why it is square centimeters and not like what we've been doing the last couple times as cubic centimeters. So let's look at example 2 then. Diana has a gift that is 11 inches long, 8 inches wide, and 6 inches tall. She has a sheet of wrapping paper that is 4 feet long by 1 foot wide. It says, does she have enough to wrap the box? And justify. So the thing we want to be looking at here is how much wrapping paper is needed versus how much she has. Also keep in mind, these units are in inches, while these are in feet. So we have to convert. So let's talk about what she has. That'd be 4 feet by 1 foot. And we really should be talking about getting these in inches. So 4 feet, if there's 12 inches per foot, 4 feet would be 48 inches. And there is 12 inches in a foot, so 1 foot would be 12 inches. So overall, the area of this sheet of paper is going to be 576 square inches, because 48 times 12 is 576. All right, now let's talk about what she needs. So we're going to be looking at surface area again. 2LW plus 2LH plus 2HW. Now I know this is in the same order, but with adding it doesn't matter. So, length, width, and height. It says it's 11 inches long, so the length is going to be 11 inches. 8 inches wide, so it's going to be 8 inches wide. 6 inches tall, so our height is 6 inches. Start substituting. The length is 11, the width is 8. Next one, the length again is 11 and the height is 6. And the height and width now are going to be 6 and 8. So we have 6 inches and 8 inches. Going through this, 2 times 11 is 22. Times 8 inches is going to get you 176 square inches. Next one, we're going to be doing 2 times 11, which is again 22. Times 6 is 132 square inches. And the last one we have is 2 times 6, which is 12. And then times 8 is 96 square inches. Now if we add all of those together, we get the surface area is 404 square inches. This is what she needs. This is what she has. So yes, she does have enough. And the reason why is because 404 square inches is less than or equal to 576 square inches. So yes, Diana has enough paper to cover her gift. Now, if we have triangular prisms, same thing. The surface area is going to be the area of the bases plus the area of the faces. Now, in this case, area of the base is going to be the base times the height of this triangle, so length and width, divided by 2. So this is length and width divided by 2. But there are 2 of those, so we're going to multiply that by 2. Now here's where it gets a little bit tricky, because now we're going to be looking at these sides of the triangle. And those might not always be the same, so there really isn't a specific formula that we can use for that. But what we can still do is say, well, what are the area of all the faces? So in this case here, we would have a 4 times 14, which is something that we were used to before with the rectangular prism. But now we have this 3.6 and this 3.6 as well. We know that it's 3.6 because this side back here says it's 3.6. So really, we're going to be looking at a formula that is LW plus, and we're going to say F. And this is what those area of the faces are. So we have to go through and do each one of those faces as an individual, so we can look at how this can be done as a whole. So, first thing we're going to look at is this example here. Surface area, bases, plus faces. Area of the base is 10 and 7. So 10 times 7 is 70. Divided by 2 is 35. But there are 2 of them. So this is going to be 35 times 2, which is 70 square feet. So again, 10 times 7. So we got this by going 10 times 7, which is 70, divided by 2, which is the 35. And because there are 2 bases, it is now 70 again. Now the faces. We have 3 different faces on a triangular prism. So we have this bottom face right now. So 10 times 12. That's one of the faces. Now we have this face on this side and the face on the back. Now this side here says 8.6 feet. The back side would also be 8.6 feet. So we have 2 of those at 8.6 feet and still this 12 feet here. So if I go through and do this, 10 times 12, so I'm going to start writing stuff down here. 10 times 12 is 120 square feet. And this one is going to be a little bit more tricky, but 2 times 8.6 is 17.2. And then times 12 is going to be 206.4 square feet. Adding everything together, the ones or the 70 plus 120 plus the 206.4, the surface area is going to be 396.4 square feet. So that is how much fabric Valerie will need. So Valerie needs 396.4 square feet of fabric. All right, that is going to be the end of lesson 6. If you have any questions, please let me know.